So let's get an introduction to our graph transformations. So we're going to be looking at our function sine of x. Just keep in mind, all of these transformations are exactly the same for cosine of x. We just kind of default to talking about sine. All true for cosine as well. So anywhere I write sine here, I could also be writing cosine. We're just going to stick with one of the functions. Before we get into that, let's talk about the Desmos graphing calculator quickly. So when you're in the Desmos graphing calculator and you get started, it will look like this. To graph a trig function, you can type in sine cosine, so you can just do SIN. There's also this keyboard in the lower left, and I believe under functions, there you can actually grab the sine function. So you can also grab it there. I'm going to just type in sine, and then I'm going to use parentheses so I can see my input value. Now, from this, we can see there's 1, there's -1, but what might be kind of tough is visualizing where those radians are occurring. So what we can do is change the settings. I'm sorry, it's a little off of my recording screen here, but basically where my mouse is here, if you go a little to the right, there should be this wrench in the upper right-hand corner called graph settings. So I'm going to open that up. Now first off, take note of whether you're working in radians or degrees. It's going to default to radians, which is typically what we're working in. We don't really graph that often in degrees. We absolutely can, but just doesn't occur that often. So, radians. If the white screen hurts your eyes, which sometimes happens to me after a long day of doing a lot of these, you can reverse the contrast. That's kind of a nice new feature they have there. If that helps your eyes. If it makes it worse, don't use it. And then from there, let's set up our axes. Really, my y-axis is fine. If I wanted to see more of what was going on, like kind of zoomed in, we can make that smaller. So we could go from like -2 to +2, and I could really see my graph. I'm going to leave that as is for now. But the x-axis, this distance it's covering is great. I'm seeing a lot of information there. What I want to change is the step. And if I want it to match the graph I was making before, I would want to change that to pi/4, which you can either type in with a keyboard down here. If you ever need to type in pi, you just type in pi, so p and then I, and it changes to the symbol. And then I just want to divide that up by 4. So now, I close that down. Yeah, pi/4. So now I can see my pi/4, pi/2. You can see it's kind of marking those crucial points that hit the midline and the peak and the minimum as well there. So now it just helps me visualize where I am in terms of radians. Alright, so with this, we're going to play around with what happens when we add, subtract, multiply, divide within our function. Now, as a refresher, we're looking at graph transformations just like we do in Math 141. So if you have some function, we could multiply by something outside of the function. We can have something multiplying inside the function. We could have something adding or subtracting with x inside the function. And then we could be adding or subtracting something outside the function. And with these, each brought about different transformations. So this value A was a vertical stretch or compression. And then B was a horizontal stretch or compression. C was a horizontal shift. And D is a vertical shift. And in our module, I included my lecture from 141, so if you need to review these concepts, I highly recommend going through that and getting some practice, because those 4 pieces are exactly what happened here. So we're going to be seeing these same transformations. What's going to change a little bit is our terminology, because now that we have this terminology in terms of period, amplitude, midline, which really make the structure for our periodic function, we're going to see how those transformations relate to that terminology. Okay, So now we can start making our transformations. So what if we add 2 to the outside of our function? So I'm going to keep sine of x there, and as contrast, I'll look at sine of x, and then if I do plus 2. So adding something to the outside of our function should be making that vertical shift, and it can be a vertical shift up or down. As you can see here, what this did is it picked up our red graph there and bumped it up 2 spots. So where I had 0, 0 before, now we have 0, 2. Where I had my pi over 2, 1, now it's pi over 2, 3. So all of our y values, our outputs, got bumped up 2 spots. So just to fill in what's happening on our graph here, everything moved up 2 spots. So I'm just going to look at those key pieces there. Let's see, 0, 2, and then 1, 2, and that should do it in terms of seeing enough values. So, and I'll just connect the dots there. With your graphs, just do the best you can. You can even tell with the pen on here, it's a little tough. Mostly what I look for are those key values going through the maximum, minimum, and midline values. And then another thing, like a common mistake is students connect this with straight lines, and that is not okay. So try to get some curvature in there with these. Doesn't have to be exactly perfect, just as best you can. Alright, so with that, in terms of the transformation that we saw, this was a vertical shift up 2 units. So this is a case where we're taking our trig function and we're adding something to the outside, which we're going to call d. And with that, we could have subtraction, and then subtraction would just mean that we shift it down instead of up. So positive goes up, negative goes down. So in terms of our pieces that we're going to talk about, amplitude, period, midline, we want to notice what changed here. So we started with this amplitude of 1. We still have an amplitude of 1. So amplitude didn't change. Period, 0 to 2 pi, or sorry, just a distance of 2 pi is still the same. So here we can see our period of 2 pi. This is a little different than how we graphed, but it's still a distance. We have this distance of pi plus this distance of pi. So before it starts repeating, there's a distance of 2 pi, which is still occurring here as well. So the period didn't change. What did change is the midline. Originally, we have our midline of y equals 0. Now, our midline is y equals 2. So, this transformation changes our midline. So this is what I'm going to describe under the effect. So what we did is we moved our midline. Midline is shifts up 2 units. So, if we have this sine of x plus d, whatever d is coming through in our graph, that's going to determine our midline goes there. It's y equals d. If it's positive, then it's on the positive side of our x-axis. If it's negative, it's shifting down, which would be on the negative side of our x-axis. So, with that, if we're adding and subtracting something outside of our trig function, that's the effect. It moves our midline. If we multiply something on the outside of our function, so let's look at what happens here. So if we do 2 sine of x, what we can see is a lot of the key coordinates stay the same, but now our minimum and maximum values are higher up. It stretches further, and this is our vertical stretch. It's stretching everything by a factor of 2. So where we have this maximum of 1 here, now we have this maximum of 2. And then we can even play around with different numbers. If I did 3, it stretches it even further. If I had a fraction, so like a half, it compresses it, so vertically it shrunk down by a half. And we could have done a third, and it would shrink down by a third. So this value that I'm multiplying by out front is doing a vertical stretch or compression. So for 2 sine of x, what we're seeing is this doubling of our y values, which means anything that's on the x-axis stays put, but anything off of the x-axis stretches. So, this is our vertical stretch by 2, but it could also be a compression. It just depends on the value that's out front. Basically, whatever your y value was, you multiply it. Now, in terms of midline of our graph, midline is still the same. In terms of period of the graph, still a period of 2 pi. What's changed in our graph is the amplitude. Our amplitude stretched to a distance of 2. And you could notice that our range changed as well. Our domain is always going to be all real numbers here, but our range is going to change based on how we shift and multiply this amplitude, all of those things. So, our amplitude is now 2. Amplitude is now 2. So in general, what's going to happen is if we have something multiplying out front, which we're going to call a, so a times, and then our trig function, whatever that value a is, that's going to be our amplitude. So amplitude equals a. Now real quick, let's look at what happens if I make that a negative value. If I put in a negative value, we still have this stretch of 2. We can see these maximum values are still ending at 2, and minimum values are still at negative 2. So our amplitude is still just 2, and our amplitude's always going to be positive. What the negative did was a reflection over the x-axis. So if I just take out that 2 there, what we can see is where, so 0, 0 stays the same, but where I was at pi over 2, 1, now we're at pi over 2, negative 1. So anything on the x-axis stays put, but all of our y values where they were positive are now negative, and where they were negative are now positive. So with that, when we look at amplitude, really it's the absolute value of what a is. It should just always be positive. And then if you have this negative coming out front, so if a is negative, that means reflect over the x-axis. All right. What if we multiply inside the function? So I'm going to take that out and plug into there. And with this, I'm going to make sure I can see 0 to 2 pi clearly. So here is 0 to 2 pi. What's changed is kind of the, I think in terms of like the frequency of how often we're reaching those maximum and minimum values. It's increasing, happening more often. So if we follow our red line here, 0 to 2 pi, you can see we start there, and we complete that period 0 to 2 pi. Now if I follow the blue line, starting at 0, 0, following the blue line, I now complete the period from 0 to pi. So what's happened is a horizontal compression. So it's compressing towards that x-axis, or sorry, towards that y-axis. It's shrinking those x values in. If I did a half here, it stretches it out. So now I'd have to go out to 4 pi on my blue line here to see one full period. So multiplying in there is our horizontal stretch compression. When we have a value of 2, that's our compression. So 0, 0 is going to stay the same, but where I had pi over 2, 1, that distance to pi over 2 is now cut in half, so now our value of 1's there. And then where I was seeing pi 0, now that's going to be pi over 2, 0. And where we had 3 pi over 2, negative 1, that distance is now half. And then we can complete the rest of our graph. And just following the trend on the other side. Alright, so now you can see our graph there. There. So this was a horizontal compression, and even though we're seeing 2 show up in our function, really it's a compression by 1/2. So with horizontal, it's that we always think about 1 over that value, so that's where when we look at sine of 1/2 x, and it's actually causing a stretch, that made a stretch by 2. So we kind of think of the reciprocal of that value that's showing up in there. So midline stays exactly the same. So the midline is not moving. The amplitude is still 1, so that's not changing. What is changing is the period of our graph. So where the period before is 2 pi, now we're seeing the period occur in just pi. So our period is now equal to pi instead of 2 pi. So what we're going to do here is that if we have some sine of b times x, this is going to divide up our period. Or really we're thinking about this reciprocal. Again, it's kind of like we're thinking of 1 over b. So that's going to be part of this. So for us, where we went from the original period of 2 pi, and then the new period, what we did is where there's that horizontal compression of 1/2, it's like we took 2 pi and divided it by that value that's showing up of 2, which gave us that value of pi. So our rule is going to be that if we see that sine of bx, we can calculate the period by taking 2 pi divided by that value of b. So if it's 2, we plug in 2. If it was 1/2, I'll do this kind of on the side here. If it was 1/2, so we saw how that stretched out to 4 pi. So if we have 1/2 there, we just take care of our complex numbers. So we'd multiply by 2, and multiply by 2, and that would give us 4 pi in the numerator, and then 1/2 times 2 is 1. So when we have fractions, we'll have to do that little bit there. Just like with our amplitude, plugging in negative numbers, inside causes a reflection over the y-axis, which actually looks exactly the same as the reflection over the x-axis here. So if a negative comes through, it still has the same effect on the period in terms of stretching or compressing. It's just it's negative, we also have that reflection in there. So in terms of calculation, you might see these absolute value bars come in here. It's just the idea that period is always positive. And then if we're seeing a negative value for b here, so if b is negative, then we're reflecting over the y-axis. That's technically what's happening, but it looks just like our reflection over the x-axis. Alright, our last piece here, and then we'll talk about our general form and how this all comes together. So, if I have sine of x, and I do minus pi over 2. What you can see is kind of the general shape hasn't changed. What we did change is where the values are occurring. So where we had 0, 0 originally, now it's over here at pi over 2. Where we have our maximum at pi over 2, 1, now that's over here at pi 1. So what we did is we picked up these values and we moved them to the right by pi over 2. So this is our horizontal shift. So what we do is we pick up these values and move them over that distance that's described, which in this case was pi over 2. So our graph should look like this. So midline stays the same. Amplitude stays the same. Period also stays the same. What's occurring here is called a phase shift. Shifting the phase of our graph over. And in this case, it's a shift to the right. So seeing that sine of x minus pi over 2, reading that it's a horizontal shift right by pi over 2. And we just need to remember, as when we originally learned our transformations, this came through of like having f of x minus a number versus seeing f of x plus a number. Kind of behaves opposite of what we think it would be. So when you see subtraction in there, it's a shift right. When you see addition, it's a shift left. And how we would describe this is a phase shift right by pi over 2. And it's going to be the same thing. So if, in general, we'll call this letter C. So if you see sine of x plus c, and then it just depends on whether it's negative or positive, that number will determine our phase shift. So if you see sine of x minus c versus sine of x plus c, if you see subtraction, that's a shift right. And if you see addition, that's the shift left. Alright, so with all of that, getting to our general form, and again, this could be cosine, and all of this stays the same. It all remains. And what we're going to see here is A is going to tell us about the amplitude. B is going to tell us about the period of the graph. C is going to tell us about the phase shift. And D is going to tell us about the midline. Notice inside the function, B has to be factored out. So if you have multiple values in here coming through, in order to see B and in order to correctly see C, you would need to factor out the value for B, and it would just be whatever's multiplying with X. So what we get from this is how we'll read it is the amplitude is just equal to A in the positive version of A, so you could think of that with absolute value. B tells us about the period, which will take 2p divided by B. That should always be positive, so you could think of that as having absolute value as well. C tells us about the phase shift, so a horizontal shift. And then D tells us about the midline, which is a horizontal line going through wherever D is. C can be positive or negative, D can be positive or negative, and I'll just tell you the direction that you're going in.